This is everything you need to know so that you can surface mount solder like a pro and build epic PCBs for your projects. In this video, we're going to learn why we even surface mount solder, the 3 different methods, the equipment you need, and the proper technique. So firstly, why do we surface mount solder? Electronic components connect to a circuit either with metal pads or with metal pins. With metal pins, you have to insert it into the hole of a PCB and then solder on the other side. With metal pads, it mounts directly to the surface of the PCB with solder forming the connection. Components with pads are called SMD. Surface mount soldering allows you to use a lot smaller components, which means that you can make denser, more complex circuits. It also allows you to manufacture boards quicker. Instead of manually having to solder each leg individually, there are techniques where you can just solder all the pads at once. Now you know why surface mount soldering is goated. Let's get into the 3 different methods that I use for surface mount soldering. Number 1 is pad by pad using a soldering iron. Number 2 is component by component using a heat gun. And number 3 is the entire board at once using a hot plate. The first method is soldering using a soldering iron. The tip gets really hot and you use it to melt solder wire onto the pad of the PCB and the component, which joins the 2 together. You can only solder 1 pad at a time, which means that large boards will take a long time to make. But this means that you can dedicate all your focus to just 1 pad without worrying about heating the surrounding components. So first up, you will need a good soldering iron. I use the Weller WE1010 soldering station as it heats up fast, lets you control the temperature, and you can also change tips. You're going to be soldering really small components, so you need a fine tip. I use the 0.8mm tip for SMD soldering versus the 1.6mm tip, which I normally use for general work. Next, you'll need the solder wire. Thinner is better, so I use the 0.6mm for my SMD work versus the 0.8mm which I use for my other work. The type of solder I prefer is around 60% tin and 40% lead with a rosin core. Lead is poisonous, so unleaded solder exists, but solder that contains lead is just easier to work with, so I always just use it. Just make sure to wash your hands and don't breathe in the smoke. Rosin core means there's flux in the center of the solder wire, which helps it to stick to other materials. You also need flux separately. I have it in a nice syringe, which makes it really easy to apply on the circuit board. You also need solder wick to remove solder, and a good pair of tweezers is also needed. You also need a magnifying glass so you can inspect solder joints closely. A lot of pros have these massive microscope setups, but I find that this little thing does almost the exact same thing, and it's like 10 bucks. Lastly, you'll need all of the cleaning tools. IPA serves as the main cleaning agent. Get it in a spray bottle. Then you need Q-tips, a toothbrush, and paper towels. Now that we have all the tools, let's get soldering. So I'm going to show you the steps with 3 components: a medium capacitor, a small resistor, and an IC. Let's start with the medium-sized capacitor. On the board, its designator is C5. First step is to clean the area. Spray the area with IPA and then wipe it down with a paper towel. Then turn on the iron and make sure that it's clean, so wipe it on a damp sponge or some brass wool. Press the iron against the pad and feed in a small amount of solder. Your pad should look like this with a nice bulge. This is too much and this is too little. If there's not enough, you simply just add more solder to the joint until you have a nice bulge. But if there is too much, you use solder wick to remove the solder, leaving it bare so then you can try again. So now that you have a nice bulge, using tweezers, place the component onto the pad and use the soldering iron to melt the bulge so that the solder sticks to both the circuit board and the component. Make sure that the component aligns properly and then remove the iron. Let it cool, and now your component should be stuck on there pretty nicely. If the solder does not flow to the component and the pad when you melt it, then add a bit of flux, which will make the solder flow easily when you heat it. Next, you want to solder the other pad. This part is pretty easy. Just press the iron to the pad and feed in the solder. So now that it's done, we need to perform a quick visual inspection. So this is where you use the magnifying glass and make sure that all of your joints look well formed. After that, throw up some IPA and wipe it down. And that's how you surface mount solder medium-sized components. Now, let's do the small resistor. We're going to be soldering R8. The process is pretty much the same. Clean, tin 1 pad, the bulge should be around this big, place the component on, solder the first pad. If the component ends up moving sideways, keep the iron there and then use the tweezers to reorient. And now do the second pad, inspect, clean, and that's done. Now, let's do the IC. We're going to be using this PCB from a previous project and soldering U3. First clean, then tin a corner pad. Place the component on and melt, making sure the components are all aligned. Then you want to solder the opposite pin. After that, you can just solder the rest of the pins. Use flux if you need the solder to flow better. Inspect and clean. And done. Cool. Now let's get into method 2. With method 2, you apply solder in the form of a paste. Stick a component on, then use a heat gun to blow hot air over the component until the solder paste melts. With even smaller components and denser circuits, soldering with an iron is really hard to do. Like, how am I even supposed to get my tip in there? Or like with this component, the pad is literally underneath it. So I like to use a heat gun when I want to solder a small component or a small group of components all at once. If I want to solder an entire board in one go, I'd much rather just use method 3. First up, you need a heat gun. I use the 300 watt SMD hot air gun by Micron, and I use it because it features adjustable temperature, airflow, and interchangeable tips. Then you need the solder paste. We don't use solder wire, we use solder paste. This stuff is made up of tiny solder boards and flux. I use the ChipQuick TS391LT, and I love this stuff, man. Normally, you have to refrigerate solder paste or else it becomes unusable. But this stuff is thermally stable, so you can just have it next to all of your other tools, and it will also last you about a year before it expires, which is a lot longer than the other stuff. To help you apply the solder paste, make sure that you get it in a syringe with a fine tip. Also, you might want to use a stencil. It's a custom tool that helps you to apply the solder paste evenly. I'd recommend using it if you're working with a lot of really fine pitched ICs. This portion is sponsored by JLC PCB. When you order a PCB, you drag your manufacturer files into their website and it brings you to this page. From here, you just scroll down, click stencil, and make sure that the dimensions is big enough. The smallest area option is 30 by 26 centimeters, which is really big. Then you hit order and it's only $2 for 5 PCBs and $7 for a custom cut stencil, which is pretty freaking nuts if you ask me, considering the quality and the reliability of these circuit boards and stencils. It takes them 2 days to make a PCB and 1 day to make a stencil. It also takes them less than a week to ship to Australia, or about 2 weeks if you get the cheaper shipping option. But normally, when I work with the stencil, it's so I can apply solder paste to the entire PCB and solder everything at once. But with the hot air gun, I like to solder no more than a small group at once. So with method 2, I apply the paste manually and leave stencil stuff for method 3. Next, you need Kapton tape. So this is ultra heat resistant tape, and it helps you to protect certain parts of the circuit board. Since you're essentially blasting super hot air on the circuit board, if there's plastic connectors, wires, or even other components that you've already soldered, the heat gun can easily melt the components, so you want to use the tape as a heat shield to protect it. And of course, you need the flux, tweezers, solder wick, IPA, and magnifying glass, and lastly, a soldering iron just to touch up some joints. Now that you've got all your tools, let's get into the step-by-step process. I'm going to demonstrate this soldering process using a small resistor, a tiny resistor, and a QFN sized IC. First is the small resistor R11. First you clean the working area, then you apply Kapton tape to protect the areas where you don't want hot air to go. I'll apply it to capacitor C5 so that it doesn't come loose. The bigger the component is, the more heat you need to melt it. So actually it's not completely necessary to apply tape, as R11 will probably melt first, but I'm just taking a precaution. Second, you apply the solder paste. You want to apply a decent amount to all the pads of the components. This is just right, this is too much, and this is too little. Third, you want to place the component on the pad. Make sure that the components sit flat on the PCB. You can give it a little tap on the top with your tweezers. Next, you want to turn on the hot air gun to 300 degrees low airflow and wait for it to get hot. You can blow it on your hand until you can feel that it's hot. Then you want to evenly preheat the PCB by moving the nozzle about 5 centimeters away in circular motions. Then you start to notice that the paste turns into a liquid. That's the flux starting to melt, and that's your cue to lower the nozzle to 1 to 2 centimeters above the board and start focusing on just the solder paste. And as you apply heat, the solder will melt and form shiny joints and pull the component to the perfect orientation. If the component half flies off, keep blasting it with your heat gun and use the tweezers to reposition it. And if it completely flies off, then just keep blasting and then stick it back on quickly. Straight after the reflow, you want to remove the heat. Then you want to do a visual inspection. A good joint should be shiny and well formed. You can touch up the joint with flux and an iron, or solder wick if needed, and after that, you just clean the board again, and that's a beautiful joint, man. Alright, now let's do the tiny resistor R4. Apply the solder paste to the pad. You have to be really precise with this. Then place the component on. The component might stick to your tweezers, so make sure to clean any residue on the tips. Sometimes I prefer to use plastic tweezers as they stick less and are easier to hold, which give me more precision. It's also easier to load the component away as it's so much smaller. Other than that, the process is pretty much the same. Reflow, inspect, clean, sweet. Now, let's solder this QFN package IC. With a pad on the bottom and lots of tiny pads, it makes it almost impossible to solder with just a soldering iron. It's also impossible to apply the paste to each individual pad. So instead, just draw a line of paste along all of the pins and leave a dot in the center. Now, drop the component in and properly align the component. Make sure that the pin 1 markers are in the same corner. Then you just want to heat gun it, and if it shifts to the wrong position, you use the tweezers to readjust. Once it's soldered on, perform the visual inspection. If there are defects, add flux and iron it out, and after that just clean it up and nice! Also, when working with an entire PCB, I make sure to solder the large components first, as they require more heat, so take longer to reach the soldering temperature. So if there's already small components soldered on the board, and then you try and solder a large component, it might cause the small component to reflow again and move, or even worse, overheat. Also, if you have circuit boards with components on both sides, you'd reflow the top side first, then use a soldering iron to complete the bottom side. Or if you're feeling daring, you can use a heat gun for both sides, but when you solder one side, the components on the other side might fall out. Ideally though, you just want to design the board so that most, if not all components are on one side. Sweet, now let's get into method 3. If you're reflowing an entire PCB with multiple surface mount components, you will need something that can get the entire PCB hot at once in a controlled manner. Two options are a reflow oven or a hot plate. Reflow ovens are big and expensive, great for large boards. Hot plates are small and inexpensive, great for small boards. There also exist DIY solutions, such as modifying a toaster oven, using a clothes iron, or making a PCB that just gets really hot. Repurposing household appliances means that you have to play with mains voltage, which is pretty dangerous, so I don't recommend it. But I'm a big fan of making a PCB hot plate, as it's really cheap, effective, and easy. If you want to learn how to make it, I have a PCB design course in the Robotics Academy, and one of the follow-along projects is a PCB hot plate. So click the second link in the description if you're interested. And of course, you'll need the cleaning, precision, and soldering tools, and this time it's highly recommended to get a stencil. Now that we have everything, let's get into this step-by-step process. I'm going to be soldering this entire circuit board as an example. So first, clean. Now, surround your PCB with other PCBs and use tape to secure it down. Then take out your stencil and lay it on top of the PCB, making sure that the holes align with the pads. Then you want to take off the little tip and squirt a line of solder paste on the side of a stencil. Then use a card to spread the solder paste evenly. It'll fill up the gaps in your stencil, so when you take it off, it leaves this beautiful coating of solder paste perfectly applied. And if I did this by hand, it literally would have taken me 2 hours. But now you just chuck on all your components, put the PCB on the hot plate, and let it rip, baby! This hot plate uses an Arduino Nano, temperature sensor, and a low side MOSFET to control the heat of the hot plate. Each solder paste has a specific reflow temperature curve which describes how to heat it to get the best possible reflow. And because the hot plate has an Arduino, I can program it to follow this reflow temperature curve precisely. This means that every time the soldering process turns out way better than if I did it with a heat gun or a soldering iron, because I'm literally following the intended temperatures bar for bar. It doesn't mean that it's perfect though. You still have to perform the visual inspection and touch up any faulty joints, but personally, method 3 is just my favorite because it's just so satisfying. And again, if you have components on either side, you'd have to do it manually with a soldering iron or risk it with a heat gun. But preferably, you just get cracked at PCB design and design in a way that's easy to manufacture, which is why you should join the Robotics Academy. Its goal is to help you guys upskill, so there's video courses, forum to chat, and weekly calls. So hit the second link in the description and join today for free. See you there, and I appreciate you for watching.